Hello everyone, myself Himanshu and Namit will take you through our final project. It talks about automated patient stratification using clinical notes. In this project, we aim to use big data and machine learning technologies to enable automated classifications of patient health condition by processing their unstructured medical records. Background: a huge amount of patient medical history is now available in the form of electronic health records. The record consists of both structured and unstructured data. Since a lot of information is unstructured, it's hard to standardize it into medical codes like ICD. To accurately extract the medical condition of the patient from these notes, it requires expert knowledge and lot of dedicated time. But if we can build a system to classify these notes accurately, then it can definitely help in improving the medical health care. We have used the publicly available Mimic3 dataset, which consists around 46,000 patients record. We have used the free text data, that is patient notes, from this dataset. Let's talk about the tech stack. We used the Postgres, Spark and Scala for pre-processing. We used NumPy, Pandas, Scikit for feature creation, and for training we used the Keras with TensorFlow. As you can see, there are 5 main components in our pipeline: input, pre-processing, feature extraction, training, and results. We will go one by one in depth into each component and explain. So let's discuss about pre-processing. In pre-processing, we have done multiple operations. We have cleaned up the spellings, we have cleaned up the extra slashes, we have removed the integers. So as you can see in these 4 slides, like we can see how the data is transformed after doing these operations. We have done the stemming as well. As you can see, in the clumsiness has become too clumsy. So like this, we have applied lot of operations. As you can see, earlier the average size was around 2000 to 3000. Now it is reduced after processing average size of each patient node into 1000 to 2000. Now you can see in this page top 10 ICD code with their frequencies, for which we will do the classification. We have used 3 methods to do the feature construction. First one for TF-IDF, second one is a word-to-vec with the averaging across all the tokens in a patient node. Second was also word-to-vec but with the weighted averaging across all the tokens using the TF-IDF weights. We have applied, we have done couple of experiments which consists of baseline models and the complex models. We'll see the results. As you can see, this is the training set result. Random forest and multi-layer perceptron has performed very well, and SVM is the third one that has done good. As you can see in the test set, here the performance of the F1 score has reduced for random forest and the multi-layer perceptron with a huge number. This is a case of overfitting. SVM has delivered good results as expected, because SVM usually performs gives good result for high dimensional features. This is Senior architecture which has given us the best results. As you can see, it has 6 layers. One is convolution, then max pooling, then dropout, then flatten, then dense layer, then dropout, then final dense layer with the 10 outputs. We ran the experiments with the batch size of 500 to minimize the cross entropy, using the error delta as the optimizer for 50 epochs to get the good result. This is our performance of the neural nets that we built. Basic neural net, we got the 0.84 as the training F1 score and 0.64 as a test F1 score. Using convolutional neural net, we got the 0.81 as a training F1 score and 0.69 as the test F1 score. We tried to optimize for the F1 score because it takes care of both precision and recall. We were able to get better F1 score than the baseline model as well as the score mentioned in the Heron et al. Paper. We see the training and test F1 score. It can be concluded that neural networks has a bit of overfitting, as you can see in the above scores. We can try using regularization and add more dropout layer to reduce overfitting. We believe that these neural nets could give better results by tuning the architecture and the parameters more. This slide talks about the limitations that we faced in our project. It takes huge computation power and time for training these complex models, and with limited data, it's very difficult to get the good accuracy. And the spelling correction task is also takes a lot of time, and as of now that the spelling correction that we implemented can be able to correct spelling up to 2 characters only. Thank you for patiently listening to our presentation. Hope you enjoyed it.